Now we get to why you all are here tonight, which is the great presentation that we have for you. The MTS is having an electric bus pilot program that they are running, and we contacted them, and their chief operating officer, Michael Wygant, was kind enough to agree to come out and chat with us, present, and there will be a Q&A. So go ahead and hold your questions to the end of the presentation. And with that, please join me in welcoming Michael Wygant.
Okay. Evening. Really an honor. Appreciate Tyson for the invite. It's really exciting to see a large group of people with kind of the same interest. About half the time I talk to people about this and what MTS is doing, about half the crowd is for it and half the crowd is against it. So I think I'm going to have a better group here that'll be supportive of it. I appreciate it. Just a little background about me before we go through it. Lifetime resident, San Diego. Been in transportation for longer than I like to admit, but well over 30 years. Started in aviation, but about the last 28 years in public transit. There's only 2 public transit agencies in the county, and I've had the honor of working for both of them. 26 years at North County Transit District. Left my career there as the chief operating officer. And had an opportunity to move to San Diego Transit about 2 years ago, and really enjoy it. And it's really been great for me, and I appreciate those opportunities. But you know, it is exciting times. When I got into transit in late 80s, early 90s for public transit, the fleets were all diesel. You know, there were a lot of industry advancements coming up in a short amount of time, but really the push was going to, you know, from an emissions standpoint, trying to make some improvements within the transportation organizations, specifically a push towards natural gas. And so I had the opportunity to work with a company called Flexible, which was kind of the industry standard for bus transit vehicle manufacturers in 1990, and deploy the first CNG bus to the region. And we ran CNG at North County Transit from 1991 till today. Their fleet of heavy-duty vehicles is 100% natural gas, and it's only 165 buses today. They've kind of gone up and down over the years, but before that, you know, it was all diesel. So that was a pretty strong conversion, and now they're looking, you know, I don't want to speak for them, but they're also looking at EV or zero emission buses also. At San Diego Transit, a much larger fleet. They got into low emissions vehicles, just like NCT, a little bit later in the game, in the late 90s or the early 2000s, specifically to address, at the time with diesel, particulate matter. That's what the original regulation was about. But they've made the conversion also. They're about 96% or 90% natural gas today, and now we're moving into the next level from an emission standpoint, which is zero emission. So just an overview on MTS. 3,200, over 3,200 mile service, you know, area that we operate. We go all the way into, you know, out into the desert area. Our service area meets up with North County Transit District up in the La Jolla Village area off Genesee. We go all the way to the border. We operate bus, light rail, paratransit, and taxi cab service. We actually oversee the taxi cabs in the city from a permitting standpoint. The buses, there's about nearly 100 routes today. There's 630 what we would call heavy-duty buses. So that would be an articulated 60-foot bus all the way down to the smallest bus we have in the heavy-duty category would be a 32-foot bus. For anybody who's ridden the 992 route from Santa Fe Depot to the airport, that's the shuttle over the airport, that's the smallest full-size bus in our system. We also have 130 rail cars. Those are all electric, obviously, served with catenary overhead, and about 54 miles of track. We also have over 200 paratransit vehicles, or smaller vehicles, or what we call body-on-chassis cutaways, and that's what we use for some of our, like the Sorrento Valley Connection. We also administer and operate what's called our Access, or our paratransit ADA service to the community, and we do that through them. With the exception of 24 of the heavy-duty buses, they are all natural gas as of today. Those 24 are at the end of their life, and they're diesel. They're the over-the-road coaches that run the rapid routes up to Escondido. They're set to be replaced this year. Right now, it's scheduled to be with natural gas. We move 300,000 people a day, or 88 million annually. That's a little lower than our all-time peak of, and that was about 2 years ago. The bus industry and transit as a whole had some dips in ridership across the nation. And there's a few exceptions for a couple of different reasons. You know, T's and C's, the Ubers and the Lyfts, you know, access to deliveries at your house through Uber Eats and whatnot, and some of the internet services have driven some of the ridership down. Luckily, San Diego has made some changes recently and actually seen for about 7 months now an increase in ridership. So we think we've hit, you know, kind of the bottom, and we're starting to trend up. So the bus is obviously a big part of the system. You know, I like to tell people, and when I was up at NCT, I ran rail also. But until the rail can make a hard left and right turn, the bus is still always going to be the heart of the system. So, or every time there's a rail problem, it gets saved by a bus. I've yet to see the rail come save the bus when it has a problem. So it's always going to be the heart of the system. We also have some rapid routes. I mentioned them earlier, and we're always expanding service. We just went through what's called the top, or where we kind of realign and assess where the highest riderships are, increase frequency where we can get more passengers, and maybe cut back on some of the service that's maybe not as performing as well. So, not that we wouldn't want to buy an electric bus, and like with natural gas, the agency made the conversion to natural gas way before it was ever required to. We've been using renewable CNG for many years, so we're good stewards for the community. You know, not only are we providing a lot more trips per vehicle mile, obviously with public transit, but we're always trying to do it as effective as we can, but also, you know, as emissions friendly. Greenhouse gases, particulate matters have always been a focus point, not only, you know, in the industry, but clearly at MTS. But what has driven the transit agencies in the region and the state of California actually goes all the way back to the late 90s. And there was a regulation by CARB, California Air Resource Board, I'm sure you're all familiar with that, called the Urban Fleet Rule. In 1998 is when it was its first inception, but it went into play in 1999, and basically that regulated all the transit agencies in the state of California to reduce their emissions. It was initially focused in on particulate matter, soot from the diesel engines, so PM, and that was something that we were all reaching milestones based on our baseline to try to reduce the PM, and so that's how we got into natural gas. Well, in that original urban fleet rule, there was actually a provision for zero-emission buses. It specified that agencies that had more than 200 vehicles had to do a demonstration pilot program associated with a zero-emission bus, and I think the original year that would have to come into play was 2008. The California Air Resource Board was tasked with monitoring the development of zero-emission buses throughout the original urban fleet rule. And they came to the conclusion in, I think it was 2006 and 2007, that the technology wasn't there, so the requirement, in essence, was postponed or kicked down the road for a little while. Well, recently, in the last couple of years, CARB has come back to the table and said they would like to propose an amendment to the regulation specifying that agencies, now the technology is here, and we need to start looking at zero-emission buses. So knowing that was coming, and that amendment to the urban fleet rule is called the ICT, or the Innovative Clean Transit Rule. It was voted on and passed last December, so it is law today. It requires, well, the goal is that all public transit agencies, regardless of their size, will be 100% zero-emission buses by 2040. It seems like a long ways down the road, but there's a lot of challenges associated with it. Every agency has to provide what's called a rollout plan by June of next year, 2020. They have to submit it. Their own governing boards have to approve it and evaluate it, and then submit it to the state that says how we're going to meet the goal at each agency. There's some nuances based on the size of your transit agency, but basically the regulation says, and in the case of NCT and MTS, it says that starting in 2023, you have a purchase mandate. So 25% of all your vehicles that you purchase after January 1st of 2023 would have to be zero emissions. It doesn't say battery electric. Zero emissions right now basically means fuel cell, which is a battery electric bus, if you're not familiar with that. It's actually a battery electric bus with a fuel cell, or what we like to call a range extender. So it's generating its own electricity, not through just regen, but it's producing electricity as it's driving down the road. There's a couple of different ways to fuel the vehicle, but those are really your only two options. The regulation also says in 2026, that percent of 25% purchase mandate moves to 50%. It is only at this point inclusive of a 32, a 35, or a 40-foot bus, okay? I'm sure a lot of you have seen MTS's articulated buses, the 60-foot buses, the over-the-road coaches, and the body-on-chassis or the paratransit vehicles are not actually included in the regulation as of today. What the regulation says, and in 2026, and it'll probably be the year before, CARB will evaluate the market and determine if at that point in time those would be amended and added to the regulation. I'm not a gambling person, but I'm going to say clearly in the case of the 60-foot articulated bus, they'll probably be added to it just based on the technology already and where it's at and who's building them. The 45-foot bus or the over-the-road coach, like a Greyhound vehicle, probably also will be added if I had to guess. I think the cutaways or the body-on-chassis for a few different reasons will probably be the last to be added, and it's hard to tell whether or not it'll happen by 2026. But whatever ones fall within the requirement in 2026, 50% of your purchase vehicles would have to be zero emissions. And then in 2029, it moves to 100%. There's some nuances if you're a transit agency that has less than 100 what we call peak vehicles. In other words, the maximum amount of vehicles you have out on the road at any particular time. But NCT and MTS both fall into the into the large transit agency category. But the dates weren't just arbitrarily picked. Typical transit vehicle is federally funded and goes through a certification called Altoona, and that's associated to the town in which they do the testing. And they certify them for a period of time that they are required to be placed in revenue service as a federally funded vehicle. And the lifespan for the majority of those vehicles, not the cutaways, but the 45-foot and the 60-foot and the 40-foot vehicles, is 12 years and or 500,000 miles. And so those dates line up with basically a typical replacement cycle of 12 years for a vehicle, and thus by 2040, hopefully everyone will meet the goal of being zero emission. It is not a requirement to replace your vehicle, it's a purchase requirement. So in theory, I would be willing to say that by 2040, there'll be some transit agencies in the state of California that will probably still have internal combustion engines if this continues to go through, based on the fact that not every transit agency replaces a bus at 12 years. MTS is in a pretty good position. The mass majority of their vehicles are replaced. They're meeting those milestones really almost on time. NCT usually tends to run them a little bit longer, mainly because some funding issues, but just availability. So in preparation for, and we started this almost 2 years ago now, in preparation thinking that the ICT regulation would eventually be amended, we weren't sure when it would happen, MTS came up with the idea with the board of directors and our executive staff, came up with the idea that we might as well get our feet wet, okay? We could continue to buy natural gas engines, but we're pretty sure that the vehicle technology and the regulation, much like it did in the 90s, was pushed towards cleaner vehicles. Our expectation was that some form of the ICT regulation would be passed. So we decided that we would get into the game early. And when I say early, you showed the model of all the vehicles that are available. In the heavy-duty bus industry, there's been a couple that have been out there for a few years producing them. They might not be Altoona tested. They might not be acceptable to purchase with federal money, but the industry is much more in its infant state than what you see out on the open road for a couple of different reasons. But we decided we were going to go out there and see what we could find. So our original pilot program that we went to the board in, I believe it was October of 2017, was a concept that we were going to buy 6 electric vehicles and develop an infrastructure at our IAD division so that we could bring the vehicles in-house and get some of our own data specific to our operations. There's agencies that are running electric buses right now, Clearwater, Florida, for instance. It's a very flat terrain, although it's a public transit agency and they pick up passengers, and you would think it would be very similar. There are a lot of parallel comparisons, but that's a place in the nation where natural gas is very expensive and electricity is very cheap. Their operating characteristics are very flat. They have a higher route speed. All those things are things that would impact your ability to operate an electric vehicle versus natural gas. In San Diego, natural gas prices are about as cheap as they are in the country. Electricity, unfortunately, is some of the higher. So we decided to get our own fleet, and we wanted to go with an extended range option, mainly because right now with transit buses, there's a couple of different charging options. You have what we call depot charging, or charging within your maintenance and operation yards, and then you have opportunity or en-route charging. The en-route charging hurdles would be land acquisition, higher cost for the charging equipment. Transit agencies, we talked about optimization of our routes. If I build the infrastructure out on the street at a specific transit center, that bus is now tied to that transit center. So it creates some limitations. So we opted initially for the pilot to do depot charging with extended range vehicles. So we looked into what was out there, and we basically came up with a purchase agreement through the state of Virginia, the Commonwealth of Virginia, had some options that were approved by the federal government for MTS to buy 6 battery electric buses from New Flyer. We also received some additional money through what we call our state LC Top program. And so we initially have ordered 6, and I'll give you some more data about those in a minute, but we've gotten some additional money to add 2 more to our pilot program. So our expectation is within the next 18 months, our pilot program would include 8 battery electric buses, 6 which will be from New Flyer, and it's kind of undetermined where we'll get the other ones. Part of that pilot program initially was for 9 chargers. So we were going to have 6 depot chargers at our Imperial Avenue division, which is downtown. I don't know if you've ever been there. And those 6 buses would be primarily deployed there. Well, we have 5 operating divisions, 4 of which run fixed route heavy-duty buses. So we wanted chargers at those other 3 fixed route divisions so that we could mobilize a bus to another division and take advantage of its location so that we can test other routes throughout our service area, not specific to just the ones at the Imperial Avenue division. We later determined that we needed 2 chargers at each of those divisions to support the pilot program. Some of the process for the pilot program or the board's direction was to not only see if they can go around the block, but see what the impacts would be, both on a positive and a negative standpoint. So, obviously the cost of the vehicle, typical public transit bus, as MTS gets them delivered, costs about $530,000 per unit. The electric buses through the Commonwealth contract were almost $900,000 after you get all the bells and whistles on them. There is funding available, HFIB, there's the VW settlement that's coming into play. So, there are some cost incentives to actually drive it down, but just sticker price, you're looking close to a $400,000 increase price on an electric bus. We wanted to see what the overall life cycle maintenance costs. Our expectations is it'll be quite a bit less. For the time that I operated and maintained trains, light rail specifically, clearly a lot less maintenance associated to it. Electrical components, although they may be a little more expensive, they tend to have a lot less of a failure rate, and they're easier to diagnose than a mechanical component. The operating costs, as we talked about a little bit, the cost of the natural gas is really cheap in this region, but compare the overall costs and all the overall the LCFS credits, low carbon credit standards we get for those fuel. We get it for natural gas, but you'll get a higher incentive for electricity. But do a complete cost comparison on the operating and the capital side. Obviously, got to add the infrastructure into it. But then there's the day-to-day operating impact of an electric vehicle. Right now, the industry is kind of transforming, and every day, if you buy an electric, and I'm sure the same is with the Tesla or some of the vehicles that are out there today, if you buy an electric bus today, the one that's available to you next week is going to have, some advancements. One of the big ones that we're obviously waiting for and looking for is range. So the extended range transit bus that's out there right now, the longest range you're going to get with some certainty is about 160 miles for a 40-foot bus. You'll hear some manufacturers that'll tell you they can do 300 miles. I've seen even ones higher than that. Most of that is simulated, and one day they'll get 300 miles, and one day they'll get 70 miles. I've driven a few of the light-duty electric vehicles, but with a bus, there's so many factors. Heat, air conditioning, the speed of the vehicle, the average speed of the vehicle has a huge impact. How the operator is functioning, how, if they treat the throttle and the brake, in essence, as an on-off switch, what we call their burn rate or their kilowatts per mile usage will have a negative impact. So we have to retrain the operators on how to actually operate the vehicle. But through all of our analysis, we're prepared to basically put it all on the table and come back to the board and say, here's the advantages, here's the disadvantages, and now we have to plan for it. We have to plan to implement the ICT regulation. And so that's the whole nexus of our pilot. There's a lot of training that'll need to go into the employees. We do all of our own internal maintenance for the most part. You're dealing with high voltage. The rest of the bus, for the most part, is just your typical transit bus. It has all the same equipment, all the same radios, camera system. There are, when you see them out on the road, which we should be here pretty soon, they're going to be bright green and they'll have a different propulsion system. But other than that, they'll have all the same accessories that our customers are used to. So the hard part really is the infrastructure. I like to tell people, when this is all said and done, if I write a book, it'll be called "The Bus is the Easy Part." You're on your light duty application. Most of you probably have chargers at home or maybe one at work. The grid and the infrastructure is fairly simple compared to somebody who says, I need 800 buses charged at once in a 4-hour window. And they have 460 to 500 kilowatts of onboard storage, and on a daily basis they use over 400 kilowatts. And I only have 10 people to clean all those vehicles in a half hour to do it. So it's a little more complicated when you increase the magnitude of the scale. And so that is going to be the more challenging part for us, and this pilot program will help us understand some of that. But really the charging infrastructure we're using for the pilot is, we'll call it transitional. We've identified, and we'll see it here a little later, areas throughout the yard where we are just kind of putting the chargers that they won't impact the rest of the operation. So this is the New Flyer. This is not our bus. This is off of their ad. But basically, this is what's called the XE40. This is their extended range battery electric bus from New Flyer. Right now, there are 4 major OEMs, I would say, that are producing battery electric buses for public transit. New Flyer and Gillig are probably the industry standard, the most known buses throughout the nation. They're both doing them. New Flyer's been doing it a little bit longer than Gillig, but still, I would say they have less than 60 battery electric buses on the road in the nation. Gillig has even less. There are 2 other companies, Proterra here in California, that probably has a couple hundred buses out on there, and they've been doing it a few years. And then BYD from China, they have quite a few, obviously, in the Orient, and they have probably the largest number of electric buses here in the nation. As we talked about, we're getting 6 of the XE40s. What we call their nameplate on their battery storage is actually 488 kilowatts, but really the OEM says there's only 466 for use. I don't know why they don't just say 466 is the nameplate. These buses will actually come, as we explained, depot charging only. They'll have a charging port, as you see here, the standard. They'll have one on each side, gives us some flexibility on how we park them throughout the yard. They also have New Flyer Connect. Connect's the name of the system. It's onboard telematics. So every bus in our system has what we call CAT AVL. And so we know where every bus is at. And we even know, in a lot of cases, how many passengers are on each bus when they get on and they get off. And we have radio communication. But we need more with these buses because a typical bus in our system on average does about 158 miles a day. That's the average of the 630 heavy-duty buses. The paratransit vehicles, they have a higher average, but we're not kind of counting that in that equation. But that means I've got some buses that do what we call blocks that are maybe 70 or 80 miles a day, and then I have some that do close to 400. So our 40-foot buses struggle with 400 miles, but our articulated buses will actually do that with no problem. And when you have buses out there 20 hours a day, 2 operators are actually assigned that vehicle. They'll do 10-hour shifts. That's the limit that they can have, what we call seat time with the commercial carrier requirements. But that bus, there are several buses in our system that'll do 400 miles a day. The battery electric bus, when we can only safely do 150, we got some challenges. We hope the technology is going to improve, and I'm sure it will. But one of the things we're going to have to deal with is identifying blocks and identifying routes that we can put these vehicles out on safely. The plan was never to buy 2 electric buses to replace 1 CNG. So as the technology improves, we're hoping throughout the years that we can actually cover all those routes with a zero-emission bus. But I think what it's going to come down to, with some assumptions of maybe 5% of technology improvement every 2 years or extended range, at some point in time, we're going to have vehicles that the battery electric solution won't work. Our fuel cell most likely will come into play, or the possibility of en-route charging. So that's kind of our plan. But we need that New Flyer Connect system to give us live data. We need to know wirelessly while they're live out on the route whether or not they're going to make that block, if they're going to finish that day, or I need to send out another vehicle. So that's why that's important. So this is just kind of a sample template of some of the data that we're looking at. Obviously, we're looking at what we call the burn rate, the kilowatts per mile. The average vehicles that are out there right now at some of the transit agencies are getting on average about 2.3 kilowatts per mile. You've got 466 kilowatts on board, but there's about 80% of it's actually usable. So you bring that down to about 375 kilowatts, 2.3 kilowatts per mile on average. You're hopefully in that 150 to 160 range safely. So we're going to build a lot of blocks associated with that. But this is an example of some of the data that we'll be getting. We'll have operators that'll perform very well. You may get down in the 1.8 kilowatts per mile, and they may squeeze out 200 miles. But I can't plan on that initially. Until the operators get to that proficiency level, we're going to have to be real careful. And so some of this live data is going to be important for us. So here, this is a picture of the chargers that we're going to use for the pilot. They're called the CPE 250s, and they put out 62.5 kilowatts kilowatts per hour to each vehicle. They have a conjoined option, so, and we'll see here in a minute, kind of, I believe, an overlay of one of the yards. But 2 of these, basically we'll have a charger for every vehicle, and they're often, one particular lane of the yard, and they can charge each vehicle. All 6 of them could be plugged in at once, and they'll take about 5.5 hours to charge them, assuming they burned up 375 kilowatts. You can also, push a button in the system, and we can charge one bus at twice the output, or 125. So we could have 3 of the 6 buses charged up if they were completely depreciated in about 3 hours, and then the next, 3 would then start to charge. So, this is transitional technology, in my opinion, as it relates to public transit, because as you'll see in some of these pictures, we're not going to be able to put a dispenser in between every bus. We have, one division, for example, Imperial Avenue is about 6.5 acres of property downtown. I think the piece of property next to us sold for about, I think it was about 5.5 acres and sold for $35 million just for the land. And so I can't buy any more property. I have to deal with that 6.5 acres, and there's 175 buses on that piece of property. And all 5 of our divisions are like that. So we really have a footprint constraint. So for me to put a dispenser for every bus 4 feet in between each other with bollards to keep us from running them over, it'd probably lose about 40% of my capacity of the yard. So that's not going to work for us. Here's an example. And this might look like there's a lot of extra room, but actually we have a built-in overtime system at MTS. These are all employees. They all have to leave by 5 o'clock or the buses won't fit. So nobody gets any overtime. There's basically 18 lanes across here, and what you don't see is the maintenance yard up here, and then there's another 12 lanes up here. And this is the border of our property right here, and this is our operations. My office is actually in here. And so the whole yard is completely full of buses. I actually have to open the gates on the other side of the property to get the buses to turn them around to bring them through the service lane. So you don't see it in the picture, but the service lane where they're cleaned each night, and then they're fueled at the CNG station and wash rack, and this is our compression station for natural gas. So when all the 175 buses are in the yard, there's no room. So for me to separate each lane of buses by 4 or 5 feet to install a charger, that's not going to work. So we're working on some other solutions there. This is just, this project has gone fairly well. Just to get to the back of it, we don't have a bus in service yet, but it's going to happen here pretty soon. If you have any familiarity with a public transit agency or even a city or state and a procurement process, they on a regular basis will take a couple of years. All of the hoops associated with it, the advertisement process, getting the bids to use federal and state money is usually pretty lengthy. This job's gone pretty well. Basically since the inception of our program in November of 17, we're looking at having our first bus out on the public probably by this August. The buses I couldn't share some pictures. I actually have them painted and wheels on them, and they actually drive around the construction facility back in St. Cloud, Minnesota, but we're not quite ready to go public. We don't want the public to see it just yet, so I can't share that picture with you. But it's moving really fast. When we get into large-scale deployments, obviously, there's a lot of planning associated with the facility. The infrastructure is really going to be the challenge. Some of the other issues we're going to have to deal with is charging software. So I got 800 vehicles, or at least 650, that are going to be with this electric or zero emission application, and trying to manage just the charging software. I'm sure you guys are all aware of when the peak pricing rates are and whatnot. It really wasn't designed about public transit when they were looking at charging times and peak pricing and super off peak pricing. Basically, when it's cheapest now, wasn't this way several years ago. The cheapest rates are, I'm out on the road trying to pick up passengers. Some of the most expensive time is right when I'm coming back in. Our buses start to come in around 8 o'clock at night. Some of them are a little bit earlier than that. But there's a lot of vehicles that are out there 20 hours a day, so I really have 4 hours to clean them, maintain them, and fuel them. In the current configuration with the natural gas, that takes 5 to 6 minutes. And some of these charging applications, it could take 5 to 6 hours. So we're going to need a lot of software and technology to help manage that. So we're going to get through it, though, I promise. We did receive a couple of, on top of the pilot program, we received a grant to extend what's called our 925 route down in South Bay. And part of the application was we had to be willing to do a zero emission application. And we were blessed to win that award. And part of that initially was 11 60-foot battery electric buses. That service is scheduled to start in 2022. So that also is ahead of the regulation requirement. So by 2022, we should have, basically 20 electric buses as a minimum in service, and that may even increase. We actually received some additional LC top money for that too, and so we've bumped it up to 12. This is going to be our first real hurdle. Right now with the pilot program, we've just identified in those 4 divisions places to go ahead and hide those chargers off in the corner and plug them in, and they won't impact the rest of the operation. I don't have much room to do that. We're going to have to come up, and we've been looking at several different agencies that are trying to large-scale rollout plans for larger than 5 or 6 buses. There's a lot of transit agencies in the United States and in the world, for that matter, aside from China, that have 4, 5, 6 battery electric buses, and they're basically charging them the same way I just assigned. Foothill Transit up in the LA area has some en-route charging. They have, to date, no real charging infrastructure in their own yards, but with all the challenges with en-route, they've actually backed away from that, and they're now trying to develop a large-scale charging network within their own yards. So this, with 12 buses, I can't just park chargers off in the corner. So we're going to have to come up with, and what we think is going to happen is an overhead system, a charging system. And I just actually returned from Europe last week, or earlier this week, and looking at, probably aside from China, the largest, I'll call it, full-scale electric vehicle application, and that's just south of Amsterdam, and it's called Schiphol Airport. And they have, in 2 divisions, they tried to put them in 1 division, they have 100 electric buses, and they're all articulated buses. And they serve both ends of the airport and into the lower section of the museum district of Amsterdam. But they have some en-route charging, but they have depot chargers for every one of their vehicles at their 2 maintenance yards, similar to what we're going to have to do. And so they've developed an overhead charging network where, in their case, the bus pulls in and there's series of stalls, just like we have, and they're bumper to bumper and mirror to mirror, so we don't have 4 feet in between them for chargers. And there's a device or a catenary wand that comes up from the bus and hits the charging network, and they can charge at different levels for their needs. So most likely that's what we're going to have to come up to try to do a large-scale application. But this will be our first real challenge. I mean, the bus is the easy part. The infrastructure is what's really we're going to have to do all the planning. Let's see, and SDG&E, they've been a great partner to us. I'm sure you guys are aware of some of their programs. With our pilot program, at this point, we're MTS is funding the project through a couple grants that we mentioned, and then some of our own capital program. But SDG&E has been a great partner to come out and do some assessments, look at some of our plans, oversee some of our consultants and our design team, and make sure they're pointing us in the right direction. For the pilot program, for the most part, we don't have any grid concerns. I think our biggest pull for the 6 buses will be about 375 kilowatts at once. Obviously, we'll need more than that throughout the day, but really the peak is what's going to get us in trouble. It's not going to be the overall usage of the kilowatt. It's going to be how much I need at once. Just to give you an idea, early assessments, 1 division, and it's not even our largest division, IAD, is going to need as much as 10 megawatts at once. That's a lot. When you let SDG&E, they're really concerned. They're thinking you're going to need a $10 million substation and about an acre to put that piece of equipment. So we got some challenges, but we'll work through it. Obviously, we're not going to need that all at once, but whatever plans we have to make sure we don't put ourselves in a corner. So it's going to be a long process. SDG&E does have several programs that we're hoping are going to help us out. Their SB 350 program, their EV infrastructure program, and so they may do what's called charger ready. They may actually come out and do not only some of the engineering and the design and the construction, but basically pipe it all into our yard to where we just put down the charger or the charging network, and they could be maintaining that system along with providing the funds to build it. So we're looking at that, and we should know more about that program probably late summer, but it wouldn't be eligible till closer to the end of the year. Also at the end of the year or early next year, we're really hoping to hear what their EV specific rate program is going to be. Right now our early numbers are basically saying that electric charging could be not quite 3 times as expensive as natural gas on a per mile basis. That's without some of the incentives, but we're hoping their new EV rate will lessen that load and kind of curtail to some of our needs. But it's really not the kilowatt that's going to get us in trouble. It's the demand. That's the real issue. And then the cost of getting the infrastructure there to support that demand. We continue to look at some other steps. We have the state and the federal government have what's called a low-no grant application, and that's for innovative ways to lower emissions throughout the state. And we've applied for that last year. We applied for a fuel cell project. Unfortunately, we didn't win it. This year, we're applying again to help us with the infrastructure for the 925 or that South Bay service that was mentioned earlier. We're also looking at the state as a consortium with several other transit agencies to do what's called the 100 fuel cell bus assessment or initiative. The big problem with fuel cells, as we kind of talked a little bit, is the cost of the infrastructure is fairly high, but really the cost of the bus. They're about $1.2 million per. So you're approaching 2.5 times the cost of a typical bus. But a lot of that is just economy of scale. There's so few of them in the country. The OEMs are saying if I could get a commitment for a larger number, we could drive the price down. So that's what we're hoping, that we can maybe bring it into the 800,000 range and then apply some HFIB funding or maybe some of the VW settlement and get them to a little more practical price. We, as we mentioned, looking at the other fundings and working with SDG&E. And we're also looking at an inductive charging pilot with SDG&E. So, right now we talked about, we have the depot charger, the plug-in. That's what we're doing with all of our pilot vehicles. You have the overhead conductive charging application where it has to touch, similar to like the trolley does. And then there's an inductive, or it's almost like wireless charging. And there's 2 companies out there right now that have been working on it. There's a couple of transit agencies that are piloting it, one up in Antelope Valley. But basically it looks like a manhole on the ground and the vehicle could pull up and a certain amount of kilowatts could transfer. The ones that are working are 50 kilowatts, which won't do me a whole lot while I'm out there if I'm burning 2.5 per mile. But that's early technology, and I think they're working towards getting it up to at least 200 or 250 kilowatts. And so that would be installed at a transit center where we have already a built-in layover for operators' breaks or meal periods or whatnot. And so if I can sit there for 10 or 15 minutes, maybe I can get enough electricity to go a little bit farther. So that is our paint scheme. That's the best picture I can show you today. But it's basically the same logo, because the bus is really an MTS bus. It just has a different propulsion system, other than being really quiet. And I've driven a couple of the new Flyer electric buses right now. They're really exciting. In Europe, I rode on several of them, and they just passed a law in Europe. All the electric buses actually have to add what they call a trolley alarm to them. They're just so quiet, and not that we don't have a lot of pedestrians and bicycles in our community, but they got, especially in the Holland area, they got a lot. And so it's now legally required for them to put some kind of audible device on the vehicle. So it's kind of funny how technology has created some other issues. But that's our new paint scheme, and our chargers are, we were hoping to bolt them in this week, but I think they're going to be probably next week. We should have the chargers in place. And the buses will probably show up, I would say, about 15th of August, if I had the best guess of that date. It'll probably take us a couple months to get them out in revenue service. We have a commissioning process that we would have with any bus, and we probably expect in about another additional 30 days with the electric bus. So anyways, it was an honor. And any questions? Yes, sir.
Where do the old buses go? Do they get dismantled or diesel? And how do you ship a new bus from Missouri or whatever to here? Is it dry or is it going to?
So with the exception of those 24 over-the-road coaches, we wouldn't have any diesels to dispose of. And I say that because with some of the CARB regulations, the diesel vehicle, once it goes to auction, federally funded vehicle, once it's fully depreciated, it goes through a board-approved auction process and sold at a local auction. It's not allowed to be, it can't be operated in the state of California again. Okay, so it would have to go out of state or out of the country or turned into parts. And for those of you who drive north on the 15 freeway where it splits on the 15 and the 215, you probably saw the 3rd largest transit bus collection in the country. That's Transit Sales International. They buy a mass majority of the public agency auctions vehicles, so that's where that diesel vehicle probably would end up. Most of the time, they just turn them into parts. Sometimes they take those vehicles and kind of clean them up, especially the older generation vehicles with some of the less of the electronic components, and they'll end up in a third world country. So that's where they end up going. A natural gas bus, same thing, it'll be picked up by the same agency, and in that case, it could actually be reused somewhere else in the state. But for the most part, they're either held as parts. I've seen them go through them and clean them up and change the interiors, and they show up at an airport as an airport shuttle. So that answers that question. As far as getting from the manufacturing plant, the buses that MTS is currently using are either made up in Northern California at the Gillig facility, and those natural gas ones would actually be driven here. They could be made in Winnipeg, and then they would go final assembly in what's called St. Cloud, Minnesota. If they're natural gas, they'd be driven here. And then some are made in Anniston, Alabama. They would also be driven here if they're natural gas. The electric vehicles will go through all of their commissioning process at the plant and then put on what's called a lowboy trailer, and they'll be driven here. So not enough charging network that would work for an electric bus for them to drive it here. I wish they would, and with the natural gas, we take full advantage of it because that's a 2,500-mile road test to kind of shake out all the problems. So, and we'll get there one day, I'm sure. So it's cheaper for them, obviously, to drive it than to lowboy it. Yes, sir.
I used to work for Sunlight Transit
Yep.
up in Palm Springs, Coachella Valley.
Well, Mr. Cromwell was there? Or
Yeah.
before? Yeah, knew him well.
Well, right after.
Oh, okay.
No, they started experimenting with electric buses 15 years ago.
Fuel cell. Yeah. Mm-hmm.
And right now they have a couple dozen electric buses. Some are, probably 2/3 of those are fuel cell. But they have a bunch of electric buses as well.
Yeah, they're just recently getting a true battery electric bus. Most of until recently, everything they have is fuel cell. Yeah, Lauren Shiver and some of the people up there. Yeah.
I just spoke to a member of the board up there, and he said they have 4 IV buses there.
Yep, the electrics. They got the full battery electric buses recently. Yeah.
And I think they had a couple more, but I think he said they have around 6
Right.
or 8. Anyway, my question is, why is it that MTS is only getting around to this now instead of a dozen years ago?
Well, I mean, there's a lot of factors. A dozen years ago, there was no electric bus. There was a fuel cell bus. Their cost per mile on the fuel cell, and they're doing reforming, is and sometimes 10 times the cost of operating a natural gas bus. So it really comes down to not just regulation, but economics of, I'm in the business of providing as much public transit service as I can. And remember, although it may be a combustion engine, for every vehicle mile, I may be moving 100 people. So from an emissions standpoint, I'm doing pretty well. Plus, I'm providing a connection to a light rail vehicle that is all electric. So it really comes down to economics and trying to provide the most amount of service for our community as possible with the little funds that we have. So that's probably a short answer to it. Knowing that, we have taken full advantage of, we've been on renewable natural gas. That's going to become the law here at the end of the year. For every public transit agency, we've been doing that for quite some time. We met our conversion to the low emission standard under the urban fleet rule, 6 years in advance of the requirements. So it's not that we're not interested in that, and we didn't not make that decision because we didn't think it was the right thing. It was just a fiscal decision for the most part.
So it's very exciting.
Appreciate it. Yes, sir.
So these vehicles are made in Winnipeg and then they're brought to St. Cloud, Minnesota and finished off? Or?
No, these vehicles, so federally funded vehicles have to be what's called Buy American. And so, and that's been in place for many years. And the percentage of the vehicle's overall cost to construct has to be, a certain percent for them to be eligible for federal assistance. So there are many years where vehicles, and when I said Winnipeg, where a certain percentage of the vehicle, the shell, for instance, some of the labor-intensive stuff is done. So you'll basically get a shell of a bus on a lowboy, and they'll take it to the final assembly plant, which in the case of New Flyer, not for this bus, but in typical natural gas bus, would have gone from Winnipeg to either St. Cloud or Crookston, Minnesota for final assembly. This bus is made 100% in the U.S. at the St. Cloud facility in Minnesota. Yes, sir.
Where do the batteries come from?
So these are Excel. I believe they're US. Well, I know they're US, but the manufacturer is Excel.
Are there any electric buses that have swappable batteries?
That concept has been out there for a little while. The theory, and if I understand you correctly, the theory would be to do charging on a battery pack, much like you would do a power drill, I guess. So you're charging isolated from the vehicle on a battery pack, and when it's come down to a level that you have to change the battery, you swap it out. I'm not aware of that in any scale in the US. I know in Europe, I got a pilot presentation from, and I'm sorry, I can't remember where it was. But in Europe, there is an application where they were doing that, but I think they were actually going away from it. Just the functionality and the time constraints of removing it. I think when I was hearing about it originally, the concept was if you could charge your battery at night or in the daytime or whenever it was most cost effective, and the battery that was in the bus would get the whole, you could actually last the whole day with it, that seemed like it was more practical, but I think what's kind of killed it is they haven't managed to get the amount of mileage they needed out of it anyways, so they were changing it in the middle of the day.
Do electric buses use regenerative braking to
Yes.
charge the battery?
Right, when we were talking about driver behavior and training and kind of training the drivers, that's the key. If you are, and I'm probably preaching to the choir here, but if you are operating a transit bus down the street and you wait to the last second before you see that light use red and you go from full accelerator to full brake, you're not going to get any regenerating. It is not wheel mounted. It's going to happen. It's not right now, but the regeneration motors are not the ends of the axles like you see on a light rail vehicle. They're in essence a replacement for the transmission. So that's going to be one of those things as technology matures, it'll become more efficient when they start to put them out on the wheel. But yes, there's regeneration.
You mentioned.
No, I was just going to tell them I'll go to the next. Sorry.
Okay. So is MTS going to own and operate the charging infrastructure? And you mentioned SDG&E's new rate schedule. Is that the public grid integration rate schedule that you're talking about, like the dynamic time of use?
Right. So first question, will we own the charging infrastructure? For the pilot program, absolutely. For the first 12 chargers, yes. As far as future infrastructure, that is debating right now in SDG&E. We're talking to them about it. They have some serious interest in it. I can see lots of advantages to it. But then when I tell them I got to do it for 800 vehicles over 5 different facilities, they're like, well, the money's probably not going to last that long. We haven't made any decisions. Their program hasn't been approved. One of the other concepts is, well, wait a minute, maybe you can use your money for the grid upgrade. Maybe so I won't have to augment that cost. Some of these substations. The Schiphol Airport in the Netherlands has that location that has 100 vehicles basically in 2 divisions, bumper to bumper, mirror to mirror, where they're using overhead charging. Each one of them has, 10 megawatts of demand. Those substations, take up more than the size of this room. I'm sure they're very costly. So maybe their program, they can spend their money towards that, at least have it at my fence line. But we're open to all options. I mean, I have no objections to SDG&E owning the equipment. We would have some concerns about their availability to come out in the middle of the night to service it, because without it, I can't put buses on the road. We don't have a backup plan. Your other question?
The new rate schedule that they're proposing, is that the public GIRs?
Yeah, but we're looking, and there's 3 utility companies. Sometimes I have to talk to groups that don't understand any of it, but I have a huge advantage tonight. But the 3 public transit or the public utility companies in the state are all coming up with a new rate plan. Some of it's going to be, SCE in the LA area. They're looking to suspend their demand charges for a while and recuperate some of it on the kilowatt charge and then phase it back in. That's the plan that they have out there. PG&E to the Northern California area is doing what they call a subscription program. San Diego Gas and Electric seems to be leaning towards that, and my math says that's a better application for us. But they won't tell us the details of what they're submitting they're just giving us a little bit of
Do
time.
you anticipate that they'd likely propose that sometime this year or early next year?
Yeah, they're telling me they should have an answer or be able to divulge what that rate looks like by the end of the year, and then early first quarter of next year, maybe apply it. So, yes, sir.
Yes, it's been great to hear about all you're doing planning to make the fleet zero emission by 2040. What crossed my mind is that, during the same time, for the next 20 years, we can expect to see the growth of automation, self-driving in vehicles.
Autonomous.
You talked about Uber, Lyft, Tesla. What about self-driving buses? Is that something you've discussed?
We've been to several conventions and seminars and presentations on it. It's out there. It clearly could develop into that. I think obviously it'll have to develop on the lighter duty application first. Not that transit doesn't like to take the step towards technology, but we're clearly, keeping an ear to it. But San Diego Transit doesn't necessarily have the resources to go test that and pilot that and design and develop that. So we'll have to wait for the OEMs to start going that direction. Obviously, there could be some advantages to it just from a safety standpoint. I mean, assuming it worked correctly, which I'm sure they'll work all the bugs out.
Could help with the range, too?
Absolutely. Absolutely. Yeah. Yes, sir.
The question about the swap, I was just also curious, what is the battery cost? What, $900,000 for a bus? How much of that is battery?
About $250,000 for the battery pack is what the OEMs are telling us. It depends which manufacturer you're talking to because of the chemical makeup of it. But I think $250,000 is a pretty good number. And time will tell how, if we can, they all will tell you you're going to assume some depreciation over the life of the bus in the range, so it will reduce over the period of time. How much that will be, what the percent-wise is, we build a warranty into the battery life based on the state of charge, over a certain period of time. We thought about trying to pay upfront for a warranty throughout the 12 years, but we're really concerned that we may be paying for a battery technology that after 2 years is obsolete. So we may be better off to get a shorter warranty, and as the batteries start to drop below an acceptable range, we either can use them on our shortest routes, or assume the newest buses that you're going to buy are going to have better range, or you replace the batteries as a midlife and take advantage of the much better technology. So that's kind of the decision we made. Yes, sir.
It looks like you're going to be dealing with some range anxiety with this. I know that long-haul truckers are incentivized to be fuel efficient, drive efficiently. Have you had any thought into doing that with your drivers, or do you already do anything like that with your drivers? Well,
we've already started the training process, and right now we're doing a high-level summary. One of the concerns is you don't want to train too much, too in-depth before you have the buses. They'll forget it, we'll have to do it again. But we did start a high-level summary training program talking about driver behavior. Some of the agencies that already have them, Antelope Valley's got a very good program on an incentive program that basically shows their performance. We show that Connect system, but basically, kind of highlight the operators who are maybe getting 1.8 and, build incentive programs, attaboys, whatever you want to call it, to try to promote them, make a game out of it. It's amazing, especially today's youth, how you can make a video game out of anything and they're into it. So I know I am, and I'm not that young. So. But yeah, clearly. As far as anxiety, what I didn't mention is we brought on a consultant early on in the pilot program. Actually, I think it was in March of 18, called CTE, or Center for Transportation and the Environment. And they're kind of the experts in the public transit business when it comes to zero emission vehicles, both fuel cell and electric. And having them, they've already been out. We've put what's called data loggers on all of our buses and gone out on every route and tried to do some analysis on the average speed, what the passenger loads, the ambient temperature, and kind of come up with some equations, some analysis to make some assumptions that on this route or this block, this bus is going to perform at maybe a 2.4. And on that block, it's going to do, maybe it'll be 1.9. And so one of the first steps when we get the pilot buses in is to take them back out on a percentage of those routes, not all of them, and try to validate that. And so that'll hopefully help us with some of the range anxiety. But yeah, clearly it will be a concern. And those first few days, I'm sure we'll all be sitting there looking at the monitors going, yeah. I'm not going to push a 38,000-pound vehicle off to the side of the road, so yeah. Anything else? Yes, sir.
So MTS is working on 2020 tax increase ballot measure, right?
Yep,
So
Elevate San Diego.
Would that be to finance electric buses?
I'm sorry, I didn't hear that.
How critical for it to have that tax increase?
Yeah, so if the question's correctly, is Elevate San Diego designed to help us implement electric vehicles? Yeah. The answer is no. No. Elevate San Diego is to get us in a situation where we can provide even more service, even better service. We're in a good financial state. The whole program is designed, if we had more money, we could provide more frequent service. We could provide additional service over here. We could go to areas that maybe don't meet our productivity levels from a ridership standpoint. What's that old movie, Build It and They'll Come? Well, if I can provide some transit, maybe I can develop some ridership. So if we had additional funding, it would be with the intent of providing more and better service. It was not designed to augment the electric buses. So, I mean, electric buses are a project that's going to happen, regardless, but, that wasn't the sole intent of it. All right. If there's no more questions, I really appreciate the time. It's been an honor.
Thank you so much, Michael, for coming out and joining us.